Welcome once again to AP Calculus BC Live. We're excited, at least most of us are excited here to be with you this morning. We got a couple of special guests, as you can see, and one of them is not real excited to be held. The 16-year-old Jack Russell Terrier is just a little bit agitated when she gets up kind of in the middle of her sleep to kind of join our broadcast here. But we thought we would bring them back because they've been an integral part of the show. And in fact, Brian, I think our dogs are the only two dogs that have Twitter handles, if I'm not mistaken. So let's go ahead and show let's show both Buddy and Wimpy before
Here's
Wimpy takes off here. Wimpy's going to take off. Go.
Wimpy's not so wimpy sometimes, I think.
Go back to your bed. No, Wimpy's not having it. Not having it at all.
I got to see, Tony. My wife gave my dog a shave haircut, and we did bad haircuts the other day with my nephew, and I think my dog would have qualified for bad haircuts of the day. So he's got kind of a good-looking haircut going on. He's a cute puppy, though.
Looks great. Looks great. A little bit more chill than Wimpy this morning, that's for sure.
He had lots of chicken fingers to keep him up here. You can see he's eating on there. So.
That's what I was missing. That's what I was missing.
The cold chicken fingers in the morning. Bye, buddy. Hey, say bye-bye. Say bye, everybody. He got his
See you, buddy.
2 minutes of phone. 2 minutes of fame. Now he's done.
There we go. Yeah, we tried to get our kids on, right? Brian and I were talking about, hey, we could have our families on. But yeah, something about teenagers getting up this early in the morning. They weren't having it, right? So
yeah, my kids wanted to be on. I said, hey, come up in the morning. You can be on. And they said, okay, we're going to get up. And this morning I asked them, are you ready? And they're like, no, we're okay.
Just us and the dogs. Just us and the dogs.
Exactly right.
Well, we're going to go ahead and get started because we have a lot of things in store for you today. Hopefully you've got your practice exam question from yesterday. That would have been the mock exam FRQ2, the shorter one from yesterday, because we are going to dive right into the solutions of that particular problem. And I will get that queued up here and share that screen. And I want to say, Brian, you're going to start us off with that problem, aren't you?
Yep. So this is the problem from yesterday. It was the 15-minute problem we practiced. If for some reason you weren't able to join us yesterday, go back and watch that video, download the problem, and then time yourself, practice the upload process again. But it's a really good practice problem to get you ready for the AP exam. It was a 5-parter on the screen here. You can see they're all kind of squeezed together. That's not how it is on the file. It won't be like that on the AP exam either. We just wanted to make sure we can get it all on one screen. So we're going to take a look at the solutions for A, B, C, D, and E today, and we'll see how you did. So here's part A. I just wanted the minimum value of the function f on the closed interval. And we're given, if you can't see it in the picture, we're given a graph of f prime, right? So we're trying to find the minimum value of f, and it doesn't really mention relative minimum or absolute minimum, right? If it doesn't specify which one, it's talking about an absolute or a global minimum. And the most natural, common way to look for one of those is probably going to be the candidates test or the extreme value theorem. So we're going to first figure out all those locations where f prime is equal to 0 or undefined, which we could find pretty easily. Looking at the graph, it happens at 0, 4, and 6. And we want to include those critical values as well as the endpoints on a nicely, clearly labeled table, and then plugging those values all into the function of f, right? We're trying to find the minimum value of f. So we're going to evaluate those. It's going to involve a little bit of integration. If you're given a graph of f prime and you're trying to find values of f, you're going to have to use some kind of integration at some point. So we can kind of use this modified definite integral or the accumulation function to find those f values. And you can see our work right there. And because we have a calculator handy for arithmetic on this exam, you don't have to try to simplify that stuff in your head or by pencil. Once you get the numbers down, normally we would tell you not to simplify, right? We say leave your answers as they are, and you don't have to simplify. But since we're trying to find the minimum, it might be helpful to know what those numbers equal so you can figure out which one's the smallest. So once we do our table, we're going to look at the different values, and it turns out our smallest value is the -1 answer, which we got when x was 6. And so how you write your answer, it wants to know what the minimum value is, so make sure we tell them the minimum value. The minimum value is -1. Right? We get a lot of questions, Tony, about problems like this. People will say, do we have to include 0 and do we have to include 4 in our table? I know they're critical values, but they couldn't be the minimum because 0 is a relative maximum and then 4 is neither. So if it's not a relative minimum or an endpoint, it really couldn't be the absolute minimum. So do we even have to include those numbers? Well, The short answer is no, you don't have to include them. But if you don't include them, you have to explain why. You can't just not include them because remember, your work tells a story. So we don't know if you understand why you're not including them. So either include them and do the work. If you're going to not use some values that you know could not be the answer, then you have to write out explicitly on that paper, I'm excluding these values because they're relative maximums or they're not a relative minimum, and therefore it could not be the absolute minimum. Because you have to write that, and because students kind of get in a rush on the exam a lot, I just have my students do the whole table. That way they don't ever forget anything or forget to give a valid reason for why. So that'll wrap up part A, and then part B on this problem is just a nice, cozy derivative problem, right? It's a function g defined as the sine of the quantity 3 minus f prime, and we're trying to find g prime. So it's going to let us use a chain rule. Take the outside derivative, sine becomes cosine, and we leave that inside part the same, right? Then we have to multiply by the chain rule, multiply by the interior parts derivative. That's where that negative f double prime of x goes. And once we have that, we can just plug in the values of 6. The only kind of tricky part to this is that you have to figure out for your final answer what f double prime of 6 is, right? We're given a graph of f prime, and now we have to figure out f double prime. And so we have to make that connection that f double prime would be the derivative of the function f prime. And if we're looking at a graph, we're thinking about derivatives of a graph, we're looking at the slope. So when we go over to when x is 6, we can see we have that positive slope there, and the slope ends up being 2. So we plug that value in, and we're going to get our answer. That second to last part of that answer, where it says cosine and then the parentheses 3 minus 0 times negative 2, you could have left your answer like that, right? Once you have your answer in there, even if there's a sine or a cosine function, that's okay. You don't have to simplify further as long as you have a numerical answer that you could type into a scientific calculator. So that was not too bad for part B. And then Tony's going to walk us through a couple more parts.
Certainly, part C shifts the focus to a BC topic and Euler's method. And you notice that you're given a particular solution to a differential equation. So that sets up the idea of slope, that this will serve as the slope of those tangent lines. And we have this initial condition, h of 5 is equal to 6. They want us to use Euler's method. We're going to start at 5. We're going to use 2 equal steps and finally arrive at an approximation for h of 3. So it's pretty clear that if you're going to move from 5 to 3 in 2 equal steps, that each step would have a size of 1. And in this case, more specifically, a negative 1. And as you can see by the carefully organized table, our iterations just show x moving from 5 to 4 to 3. The work in the problem is really devoted to finding these h of x values, these dependent variable values. And initially, we don't have a lot of work to do because we're going to use what's given, the 5, 6. Now, we've shown you a variety of ways that Euler's method can be implemented, and we're hoping by now you've maybe been able to latch on to this really wonderful shortcut that really your focus is finding out what the change in y is going to be. You've got this change in x. Now let's find that corresponding change in y and apply that to each of the y values. And that particular change in y is nothing more than taking the slope and multiplying it by the change in x. Now, if you're bothered by that a little bit, feel free to go ahead and write those equations of lines like we've shown in several videos. But you've probably, if you look very closely at these two techniques, you'll see how they merge and mesh together very, very nicely. And that this is just an extension, this is just an extension of that idea of the linear equation. So in any event, you're going to plug in your 5 here in this first iteration, and might want to do a little simplifying here because it's going to be so much easier to apply a simplified value to that previous y value. Negative 1.6 is the result, so we find out that our y values are decreasing as well. So the new y value that pairs up with the x value of 4, and when I say y value, I'm meaning specifically h of x, is 4.4. Once again, we use that new h of x value, we use that new x value, and then we lather, rinse, and repeat. And we have a new dy of negative 1.1 that once it is applied, 3.3 would be our final result for h of x when x is 3. And I think it's really important that this is an approximation. You want to communicate effectively in mathematics. And yes, there are times that we can look the other way if you don't use an approximately equal to sign. But as teachers, we don't like that. We would like you to communicate exactly what has taken place. And so let's go ahead and really make it a point. If you want to say what h of 3 was going to approximately equal, let's use that all-important approximation symbol. Moving on to part D, we have a particle motion problem that mentions the fact that we have a particle moving along the x-axis and the velocity is provided as f prime of t. So what we have is a way to sort of relate back to the original stem of the problem and utilize that f prime graph. Our job is to evaluate the definite integral from 0 to 10 of the absolute value of that v of t. And we have to use correct units and explain the meaning within the context of the problem. So once again, we have to be thinking about v as being a replacement for f prime of t and vice versa. And this idea of the absolute value couples with the idea of finding area. And so when we go through this graph, any type of area that would have lied below this horizontal axis is going to be treated as positive. That way we are ensured to get total distance traveled and not the displacement. And you can see that in this solution, we just used absolute value symbols around each specific area, went ahead and simplified them to get the 6 plus 2 pi. Of course, you could have left it unsimplified even with the absolute value symbols and been perfectly fine. As far as using correct units explain the meaning, we know that this definite integral will represent the total distance traveled by the particle in meters, get those units, and then it's very important that you close it out with the all-important time element. You want to say some kind of a preposition like during or throughout or from and to. Don't use the word at. In this case, we used from and to, t equals 0 to t equal 10, and let's go ahead and get that last unit in there in terms of seconds. All right, that leaves us with one more. And it got me thinking. I look at these solutions and I think how really wonderful it's been to have Ted Gott put these together for us. How many times have you heard us say solutions by Ted Gott? And I just wish that we were able to do a little bit more with that. But I do have a picture of Ted, so I wanted to share that with you, just so you knew that he does exist. He is a real live person, and so that's the wonderful gentleman that's been working so tirelessly, providing you with these solutions. Ted from Maryland.
Yeah, and Tony, any photo can be doctored. Any photo. So I've had a lot of people contact me. Is this a real person? You guys just making this person up? You guys keep talking about them. So I think there's still going to be some conspiracy theories. So let's go one step further, Tony. Instead of a photo, what if we brought the real deal on right now, today?
Oh,
Because guess what?
wow.
If you unshare your screen for a moment, hey, look who we have today with us.
Good morning.
Ted Gott, the famous Ted Gott. How you doing, my friend?
We're doing good over here in Galesville.
Well, Ted, it looks like it from the looks behind you. It looks like you're in a much better place than I am right now on your screen there.
Right.
But so
That's St. Thomas, Virgin Islands.
oh yes. We're so thankful of all the things that you have done for us. And we want to we wanted to bring you on today to prove to people that you are a real person, but also just thank you in person for your tireless efforts to do all these things every day. And you're getting these problems sometimes at the last minute and just typing all these beautiful solutions up and saving us hours and hours and hours. And I have my own conspiracy theory, because when Tony and I started dividing up these tasks for these videos, I was going to write a lot of the problems, and then Tony was going to design a lot of the slides and presentations and do the solutions. Then all of a sudden, next thing I know, he's like, guess what? Ted Gott's going to do all the solutions for us. And I was like, I don't know how I got bamboozled like that, but we are thankful, Ted. Since you're here, let people know real quick. I know Tony mentioned you're from Maryland, but where specifically? Tell us a little bit about your background, and I have to also know about the shirt you're wearing today.
So I live in Galesville, Maryland, and I taught at Southern High School. We're close to Annapolis, and I taught there for 42 years. I was also a student there before that. And my shirt is one that our calculus class in 2005 made. And back then there was an advertisement on TV about got milk. And so they kind of did it on that theme. And on the back is my picture, and Ted got it.
I love
With
it.
the
I love
milk
it.
mustache. I love
Well,
it.
Yeah, the milk mustache. Yeah, that they had to paint that on me. I can't believe I ever let them paint on me.
Well, Ted, thank you again for joining us today. We so much appreciate it, and thanks for joining us. We're going to go ahead and maybe jump back into part E, Tony. Is that all right? If you can.
Yeah, I
do
think
part
that's
E?
what we're going to do. But you know what? I have an idea.
What's that?
Since Ted's here, why don't he debrief on this particular last problem? I think that would be a great idea. In fact, it's the last problem that we're going to debrief. It seems only fitting that Ted takes that honor. Ted, would you like to do that?
Sure, sure.
All right, I'm going to go ahead and share my screen again, and we're going to move to part E. All right, Ted, take it away.
So in part E, we have to write a third-degree Taylor polynomial to k about x equals 6. So we need to know k of 6. You can see that from the definition there, that integral will be 0. So we've got 12 for that. Then we've got to find k prime, which involves f of 6. So we can, then I was a little concerned about that, but they told us up in the stem what f of 6 was. So we have that. Then in k prime, we end up needing to know f prime at 6, and we can just read the graph for that. And then to find the third derivative, we're going to need the second derivative of f, and we're going to have to use the slope from the graph to get the slope of 2, and then we've got to take the opposite of that, so we get the -2. And put all those parts together, we've got the third-degree Taylor polynomial, we've got k of 6, we've got f prime, k prime of 6 times x minus 6, then we've got the second derivative over 2 factorial, x minus 6 squared, and then we've got the third derivative over 3 factorial and x minus 6 cubed. And on the exam on Tuesday, just stop. Don't go any further, because you won't gain any more points and you might lose something by simplifying incorrectly.
Great job, Ted. Thank you again for joining us, Ted. You've been an amazing friend, but also an amazing resource for so many teachers and students.
You're welcome. You're welcome.
Wonderful.
Can I say something to the students before they take their test?
Please do.
Okay.
Certainly, go right ahead.
Yeah, good luck. And I know you've prepared well if you've been doing Brian's problems. And I always used to tell my students, don't worry about the pieces you don't know, just do your best on the ones you know how to do. So sometimes you get discouraged when there's a part you don't know. Just don't worry about it. Just go and do the best you can on the ones you do know.
That's great advice, Ted. Great advice. Ted, thank you so much again for joining us. Tony, as we transition here, let's play a game. Can I play a game with you, Tony?
All right, let's play this game, Brian.
This is called By the Numbers. So I'm going to show you some numbers. You haven't seen these numbers, but I want you to try to guess what these numbers represent as we finish up these last 33 episodes. These numbers all have some meaning. So if you're watching at home, students and teachers, I want to see if you can guess these numbers as well. So first number today, Tony, is 678. What do you think that number represents?
I would have to say the number of times that my Jack Russell Terrier wanted to bite and scratch me this morning while sitting on my lap. Am I close?
No, I was not close. That was the number of problems. Can you believe it? That's the number of new problems that we wrote. New problems for these lessons, these last 33 weeks. We had 678 problems, which is also the number of solutions that Ted got typed up for us out of the goodness of his heart. So that was 678. Next number, Tony, 33.
Gosh, 33. The number of days that I didn't take a shower during this pandemic.
Okay, it could be true. But for us, it's going to be the number of YouTube video lessons that we've done. This is our 33rd lesson with our students joining us today. So I'm now that I've heard that you haven't showered 33 days out of those 33 lessons, I'm kind of glad that we're distance remote, that we're not face to face. It would have been a much more rough week. 14, Tony.
14. I guess the age of my youngest daughter. I don't know.
I'm going to assume that's correct. Please, I better be right. But no, that is for us. That's the number of nights I've kept you up past 3 a.m. to work on these lessons for these videos. I know that you're kind of a late night person. I think maybe you thought you're more of a late night person until we started this project, and then now we're kind of both learning what late night really means.
you redefine late night.
Yeah, 14. I owe you some sleep. I apologize for that. This is a big one. 753,197.
Boy, the number of bacteria that crawl over my body when I don't shower during this pandemic.
That might be an underestimate, but that's the number of views just for AP Calc BC videos. Can you believe that? Almost 1 million people. 1 million views of students trying to get ready for the exam, which is pretty impressive. I have just a couple more for you. 24.
The number of seconds on the shot clock in the NBA.
You're getting better. The number of pets that we've featured so far from our pets of the day at the end of each lesson. So 24 wonderful pets that we've been able to feature so far. And then finally, Tony, 2.
2. Oh gosh. The number of different types of AP calculus classes I teach, A, B, and BC. Am I right?
Okay, that's pretty close. It's actually the number of times that Steve Kokoska, the former chief reader and test development committee member, has joined us on these live sessions for our special guest.
But wait a minute, Brian, I think you have a mistake there. Steve's only been with us one time.
He's only, oh.
Yeah.
Well, what if I told you, Tony, that on Tuesday, this is, by the way, Steve Kokoska, hopefully you join us on Tuesday, former chief reader, test development committee member, this is the committee that writes the free response questions that we get to do each year on the AP exam. And then, like I said, the chief reader, textbook author, T-Cubed instructor, pickleball, world famous pickleball player, all these wonderful things. He's agreed to come back today to finish his presentation. We had so many emails and tweets and messages saying, we love the presentation. I wish we could have gotten through more of those slides. Is there any way you could ask him back? And I contacted Steve and I had to beg and plead, but he's like, you know what, I'm gonna do it. I'm gonna help the kids out. So he's back to join us today. So Steve, thank you, not just for coming once, but for coming back a second time and sharing a few more strategies, tips, and common errors that students can look out for on this year's exam.
Well, thank you, Brian and Tony. I'm delighted to be here again, especially on your last day. I'll be very quick. I just have a couple of common errors that I want to finish, and a couple of general exam tips, and one last comment. And I'll be quick here, I think. And interrupt me if you have a quick question. One of the common errors that we didn't get to, I think I left off with this one, is what I call a universal logarithmic integration. So don't make this mistake next week. This is the one where students will frequently just see a function in the denominator and assume that this is the natural log of the absolute value of that function. And of course, what's missing here is we don't have the derivative of that function up there in the numerator. So don't make that mistake. Here's another one, especially for BC students, and this one has to do with an improper integral, one that goes from minus infinity to plus infinity. One common error we see is that students split this up, or don't split this up, pardon me, and they write this as one integral where the limit as t goes to infinity of minus t to plus t. And of course, that's incorrect. Now, as an aside, and I'm not going to write this, but that is a way to define this improper integral, but it's not the way that we do it. The way that we do it is we have to split this up into two separate improper integrals. And we examine each of these separately. Now, the way that I wrote this is I split this up at 0, and that's a common way to do it. It's a common, often an appropriate way to split it up. But you know what? It doesn't have to be at 0. It might be, for whatever reason, because of the nature of this integrand, it might be better to split it at 5 or -6. So what we have to do is examine both of these improper integrals separately. Remember that if one of them diverges, then the entire integral up here, the beginning one, the original one diverges, and we don't have to look at the second one. So that's a common error on BC problems. And I'm sorry, Brian, but I know we're doing some differential equations. Is that correct? There are some DEs here that will be, could be
I believe
asked.
so, yes.
Yes. Okay, so good. So I know that students will not be asked to draw segments in a slope field this year, but they may be asked to solve a separable differential equation. And these two common errors sort of go together, and I'm going to talk about them in the context of a real-world problem. Let's suppose, for example, that students have to solve this differential equation. And remember that the only technique that students need to know is separation of variables. They may know some other fancy techniques, but you won't need them. So the first step here is I separated the variables. I got all the y's on one side, I got all the x's on the other, and then I integrated both sides here and I added my plus c. This is what I'm focusing on right here. Make sure that at this instant, when you take the antiderivative of both sides, that's when that plus c, that's when that constant should be introduced. You can't go on and solve this expression for y in terms of x and then say, oh, now I'll add the plus c. And in fact, right at this step, as soon as I add the plus c in there, as soon as I get the plus c in there, the very next thing that you should do that I recommend, this isn't necessary, but I believe makes the problems easier, is I would use the initial condition at that point. It is certainly possible to go on and solve for y in terms of x and then use the initial condition, but in my opinion, it's easier to do right here. So there's two things that I do at once. I add the constant of integration and I use the initial condition. And one more common area here, especially for BC students, and this one has to do with the alternating series test. And if the alternating series test fails, if an alternating series fails to satisfy one of the conditions of the AST, students automatically conclude that the series diverges, and that is not true. Now, it's not necessarily that easy to find a counterexample to this, but you cannot use the AST to argue that a given series diverges. That's the point. Okay, that's the point of this part. All right, let me end here with just a couple of general tips here that I've learned through my experience with the AP program. Look, make sure, students, that you show all of your work, especially on this exam, this short exam. We're not going to accept bald answers. A bald answer is just an answer where we expect some supporting work. You may be, and I know you're very good at these, and you'll be able to look at some of these problems and almost know immediately what the answer is, but darn it, show your work and show your mathematical setups. If you do get a problem that requires you to use technology and you have to find some sort of arithmetic intermediate result, don't round. You can write it rounded, but store it to the greatest degree of accuracy allowed by your calculator or by your technology. I'm sure that Tony and Brian have emphasized this quite a bit here. We expect that at least a longer problem will have lots of parts to it. If you can't solve one of the parts, don't give up. Look at the others, do your best on the others. Don't waste time erasing bad solutions. I understand you could just take your piece of paper, throw it out, and start a new one. But if you've got a couple of possible solutions on the page, pick one, cross out the others, okay? Don't worry about erasing it, just cross it out. We're not going to read crossed out work. Make sure you answer the question. This was very appropriate in a problem that Tony just showed you where we had a table of values. Be careful. Sometimes in those questions, we ask for the x coordinate. Sometimes we ask for the actual absolute minimum value. Make sure that you answer the question. Don't say too much. I know this. How do you reconcile these two, 1 and 6? Don't say too much. Look, if you've got the answer, I know you've got a lot of information that you want to tell me that you've learned, but be careful. If you say too much, just as in simplifying a numerical answer, you may lose a point. And this has already been stated here once, don't simplify a numerical answer, especially in this short time frame. Don't waste your time with that. And remember, set your calculator to radian mode. Fantastic. Oh, just one more comment or two more comments here. Look, I thought an awful lot about this in the last couple of weeks about what kind of problems the College Board might be asking on this short exam. And especially where we have technology and open book and open notes, I believe strongly that we're going to get some sort of graphical or tabular problem that you've been practicing. That way, students who have fancy technology, who have sophisticated technology available, will not have an advantage by using an algebraic expression for a function. So I believe very strongly that we're going to see some kind of problem that has a graphical or tabular statement or stem, not algebraic. I also believe very strongly that for BC students, you're going to see something that involves, you're going to see some sort of a question that involves a Taylor series. So to our teachers out there, look, thank you very much for all of your hard work, your commitment, your dedication, and especially your flexibility in adapting to online teaching. To the students out there, look, good luck next week. All of us here who have been involved with this, hope you'll all get a 5. And, you know, sincerely, I wish I could have all of you in my class this fall. Good luck. Thanks, Brian. Tony.
Steve, thank you so much for joining us as always. It's always a pleasure to have you here. So it was a wonderful, wonderful surprise that you're able to come back and finish that up. And I hope that the students and teachers that are listening heard that advice, because Tony, can you imagine a better reference point to hear something from than
a former chief reader, a college professor, a person who's written the exams? I think he's got the whole package in terms of the knowledge base that we would want to certainly convey to students and teachers all over the country. We're very blessed to have him not once, but twice this week.
Thanks, guys. Appreciate it. Thanks for all you've done.
Much. Absolutely. Tony, I got a couple more by the numbers for you.
All right, let's try this again, I guess.
You did so well on the first one. I thought, you know what you need, Tony, is one more round to redeem yourself. So let's see how you do on this one. This is going to be a countdown. This is the by the numbers countdown. Number 5, Tony.
Countdown starting at 5.
Yep.
Okay.
What do you think? What is 5?
5. That would be the number of men or women that would start in a basketball game on the floor.
Ah, that's true, but not the correct answer. That's the number of different mugs that Tony has used during our live lessons. I wonder if people have been paying attention to that. Tony, can you name them, do you think?
I think I can. I think the smiley mug was my go-to. That was the early one. And then I borrowed my son's Pokemon mug. He wasn't happy. And then I think I had in Indiana newspapers, I think, or for my wife's work, I think I used that. Oh gosh, there was like a breakfast with Santa, and I think Indianapolis Colts Super Bowl championship mug. Am I right?
Let's see. Your wife was so kind to send me a picture of the mug. So you might have been noticing on there the 5 mugs that Tony's been doing. So wonderful job there, Tony. Let's see if we can go with number 4 in our countdown.
No, oh boy, these are getting harder and harder. I've got it. The number of AP Calculus teachers that were doing YouTube Live, right? Tony, Brian, Mark, and Verge.
Oh, that's a great one. Yeah, I forgot about Verge and Mark. I almost combined their names like those power couples, right? Verge and Mark. No, this is going to be the number of botched high fives that we've tried live on the air, Tony. So we've had 4 pitiful attempts, and we're not even going to try one more. We've gone back and reviewed the video and realized we are out of our element. So here's actually, I got a little photo evidence, Tony. This was the day that we didn't realize our camera switched. And we were high-fiving in the wrong direction. So that was pretty bad there. What about number 3?
Oh goodness, number 3. Oh gosh, I'm starting to draw a blank. The number of times my cell phone went off in our 5th broadcast.
Let's find out. This is the number of original music
Oh,
pieces that were written and featured in these daily live lessons. You remember the first week, right? We had a shortened week. We started on a Wednesday, and all the lessons kind of just started with like silence, right? We were told we couldn't have like music playing. Remember that, because the YouTube like censors would like recognize like copyrighted music and they'd boot us off the air. So we were like, College Board had us like freaking out, and we were like the very first show. So we're like, we're not going to be booted off at 9 a.m. before anything's even been aired, right? We're not gonna be those people. So we asked for people to send them in. Can you remember who sent those in?
I can, Brian, and this really tugs at my heartstrings. You know, being such a a connoisseur of music and a musician myself. But Katie Yetman, Kareem, and Anthony G, just a wonderful addition to our program, and we're so forever indebted to you guys for helping enhance this experience, not just for us, but for all the viewers.
Wonderful. That's a great job. Number two.
Two, me and you, two of us, two.
That's pretty good. Tony, we almost forgot. This is the number of free shirts that we
Yes.
have to still give away today. It's Friday. We have 2 free shirts we have to give away to a student and teacher, right? So one lucky winner is going to win a shirt for themselves and for their teacher, right? And here's what's at stake. This is the magical shirt, which is pretty ludicrous looking, right? This is the front of it, and the back has all the tour dates, right? Which is going to be all the different topics that we've done. And so we've got one winner today. Guess who our winner is today, Tony?
I would have no idea. There's been so many submissions.
I know it's been hundreds and hundreds and hundreds and hundreds of submissions. And like we mentioned the other day, man, we really do wish we could give every single person one of these, but unfortunately we were only able to order so many of them. And also Tony and I paid for them out of our pockets, and our wives said, you're done, no more. But our winner today for yourself and your teacher is going to be for Sarah Hindman. Sarah Hindman, you have won a shirt for you and your teacher. So Tony will be getting a hold of you later today. He'll send you a message, so make sure you check for your messages in Twitter, not just in your feed, but in your message inbox. That way he can get a hold of you. That way he can make sure he gets in contact with your teacher to send your t-shirt to your teacher or your school, and then your teacher can give it to you. So that was our final winner, Tony. I wish we had so many more to give away. Number one, Tony.
One. The score that none of our viewers are going to get on their AP Calc exam.
I feel pretty confident about that. This was the number of amazing producers that we've worked with each day for the last 7 weeks. We haven't had a whole bunch of people. We've had one person every day who stuck with us, that she managed to somehow bear with us. And from the College Board, that's the person who does all the stuff, right? Tony and I just show up, right? We just kind of show up, and we don't have to worry about anything on YouTube. We're taking care of any technical stuff. They do all of that in the background. And Sarah Hunter has been on here every single day. This is the reason why the shows are so flawless. And every time it messes up, like, it's because of me, right? You see how incompetent I can be, but she's covered up so many mistakes. So Tony, do you want to share any thoughts about how amazing it's been to work with Sarah this last couple of weeks?
Sarah, you have just been fantastic. You keep the wheels on this machine turning, even from day one. I feel like we've gotten to be very close, even though we've never physically all met. But we certainly have had a lot of early mornings and pre-production meetings together, and we are so thankful for how awesome you are in the work that you also do with the College Board. Outside of just producing some videos here during a short period of time for just, and I believe physics as well. So, but thank you very much, Sarah.
Yeah, we got very lucky that we got the best producer, I think, Tony, that College Board could possibly offer. And this is not her normal job, right? She's not a producer. Everybody, even at College Board, everybody's chipping in and doing what they can to put these videos on. And I think, Tony, you would probably agree, every morning we hop on a little bit early with Sarah to kind of make sure everything's working, and she does all the technical stuff. And kind of the coolest part of the day is we hop on in that morning meeting, and we have a lot of laughs in the morning, but we get to hear her little baby talking and laughing in the background. So it's always a kind of a fun, chipper morning when we get to hop on here each day. So that was 5, 4, 3, 2, 1, right? So, wait a minute, Tony. We got one more.
0. Okay,
We're counting all the way down to 0.
Nothing. I was going to say the number of Sesame Street characters that made an appearance, but we did have one. I remember Grover stopped by.
Yep. And we're going to see him.
Brian, Zero. I don't know. I mean, how many dislikes that we've had on all of our YouTube shows?
Close, right? If we're rounding to the nearest million, we're going to have 0 dislikes on there. But guess what, Tony? 0 is the number of minutes left before I get to finally pie you in the face, my friend.
Okay, so you're still kind of thinking about this, right? You still think that this is a thing. You know,
Tony,
Brian, we've talked about this. We've talked about
Tony,
this.
look,
Oh,
and
you have your pie
it's got the cherry right there on the top for you, my friend. See,
with the cherry.
I meant business. Like I wasn't joking around. Like you're getting pied in the face, my friend.
I'm not worried because Brian, it's virtual. I've told you many times. We've talked about this. It's just not possible.
Or maybe it is.
I told you, Tony. It was coming, my friend.
You did it.
I think it was worth the wait. And hopefully College Board doesn't want your microphone back. And if they do, I don't think you're getting your deposit back because I'm not taking responsibility for that. Barely. We can barely hear you. You might even have to lose the microphone. And I apologize for nothing. This is why we did this on the last day, Tony, because I had a feeling I might have messed up something in the transmission there.
Oh, and a cherry too.
Yeah, see, I told you I was going to put the cherry on top there, my friend. So there it is. Hopefully you're able to keep going here for a little bit because I think we have
I will take one for the team.
We have some final thoughts and some tweets, right? We have to finish our final tweets.
We're going to jump right to those. Our Teacher Appreciation Week, as you will. We had so many, just couldn't get them all on the air, and I tell you, it was definitely heartbreaking because we wanted to recognize all the teachers, and it seems like as Teacher Appreciation Week progressed more and more, they just became more and more heartfelt, and it was really difficult to make the decisions to only include here just a few, but please understand they're still out there. Teachers are reading them, other students are reading them, friends of friends are reading them, and I think that students, you did a fantastic job, and your teachers are very lucky to have you, and I know that you're very lucky to have these teachers.
And Tony, before you read this, can I get you to like maybe take your headset off and then use your computer mic, because I'm sure it sounds wonderful on your end, but on our end, your mic is pretty much shot. I think we did your mic.
It is shot. All right. Well, that's just wonderful. Okay, let me do that. Let me take care of that here.
These are too important that I want to make sure everyone gets to hear their. I know that we get so many emails and messages from students and teachers both appreciating how much you've been able to acknowledge teachers, and I know that.
Can you hear me now? Can you hear me at all?
Yeah, I think we can hear you good now. Now you got that
Can you
pie
hear
out
me?
of you.
All right. That's great. That's great. Okay. Microphone 2 in action. All right. So what we got here, guess who the real world's best calculus teacher is? Drum roll. Mr. Mazzoni from Bel Air High School in Texas. He never judges anyone by their math background. He puts his all into his teaching, and he tells his students to ask him questions via any communication method, anytime, day or night. So congratulations, Mr. Mazzoni. And of course, we want to also shout out to, on behalf of all BC Calc students from Greeley, I want to say a big thank you to Mr. Bennock. Hopefully I'm pronouncing that correctly. He has been teaching for over 30 years. I know what that's like. And this is his final year of teaching. And he loves teaching, and he's impacted all of his students. So congratulations to you. Happy retirement for you. You have really deserved it. And then I want to go ahead and end with a special shout out here from Samantha. I had the best calc teacher and dad. I want to show him my love. And also I want to show some support to the teachers who have filled his shoes to help my varsity calculus class with the AP exam. Go Wizards. If you recall, Brian spoke yesterday about how Samantha had lost not just her BC calculus teacher, but her father as well. And Samantha, please know that this community, we support you. We love you. And we know that somebody's going to be looking down and smiling and being very proud over you for these next few weeks. So we want to just definitely recognize the wonderful work that your father did, and just show that we are very supportive of you. So there's our tweets. So I guess what's left, Brian? We've recognized so many great teachers. I think we may have some teachers that want to maybe share some sentiments to some students, perhaps. So what better way to do this than a special video that we've created?
Good morning and welcome to the very first YouTube Live virtual lesson for AP Calculus BC.
Well, I think that says it all.
It does, Tony. I mean, it has been the most humbling and rewarding 7 weeks, I think, for me as a teacher, not just working with my own students, but having a chance to be a small part of classrooms from the West Coast to the East Coast to countries all over the world. The amount of emails and tweets and just encouraging words we've heard from students and teachers, not just about these videos, but about how you're working, how you're still, persevering and striving for that qualifying score, not letting any circumstance or situation define who you are and define how you react. And so we've been completely humbled and blessed to be a part of this. And I'm not sure, Tony, what else we could say other than that.
Exactly. This could have been anybody else up here. There's so many wonderful AP Calculus BC teachers across the country. We're just glad that we got to be this, just some part of your studying, some part of your preparation. And, we believe in you. There's a lot of people that believe in you, and we know that you're going to have a very fantastic week next week and beyond.
Absolutely. And we were trying to think of the best, ways to send you off. And one of the things that we did is we reached out to some calculus teachers. You might have seen your calculus teacher in that video. We reached out to some calc teachers and said, hey, who wants to share with their students, how much you believe in them and are proud of them? And the amount of teachers that sent us things was incredible. And that presentation that we had that you shared had so many great teachers. And that was not even 20%. We had hundreds and hundreds and hundreds of your teachers that wanted to show you, not just their own students, but show all of you how much they're behind you. And so rather than Tony or I trying to, give you any of our best advice, we think that your teachers are best suited for that. So we're gonna close out our session today, and we're gonna close out this 6.5 weeks that we've spent with you with one more presentation, just to really put into perspective how many teachers, calculus teachers around the world are rooting for you. So enjoy this last piece here. And it's been a pleasure. And it's been our honor to be a part of that. Tony, any final thoughts before I share this?
Start that video, guys. It's been a pleasure. We're going to miss you. Bye, guys.